Welcome to Python for Engineers. This is lesson 4. Today we're going to be talking about Numpy. Numpy is one of the most useful packages around. The convention for importing it is import numpy as np. So a lot of times you'll see code with np dot yada yada. Just know np usually refers to numpy. NumPy's main object is what's known as the homogeneous multi-dimensional array. It's a table of elements, usually numbers, all of the same type, indexed by a tuple of positive integers. In NumPy, dimensions are called axes. So, for example, if we have the following NumPy object, this is a boom. Oops. There we go. This is a NumPy array of length 3, and this is a one-dimensional NumPy array of length 3 with one axis. It's got 3 elements in it. So it could represent a point in space. We might have a list of points in space, and that would look something like this. So let's say we got 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. There we go. So we've now got a 3 by 2 array, and let's see here. We can check its size as 12. We can check its number of dimensions. That should be 2. We can check its shape. We can check its shape, which is really useful. So we have a 4 by 3 array, just representing a matrix with 4 rows and 3 columns. We can call also call some helper functions, such as arange, which gives us just a list of elements, and we can reshape to 4 by 5, or we can do 5 by 4, or we can do 5 by -1, which is the same thing, or we can do -1 by, let's do 4. We can do 5, and what's cool is that NumPy will automatically figure out this dimension. We can do -1 by 2. If we do it by 3, we can't reshape 20 into anything by 3, just because it's not divisible by 3. One quick note about making arrays: you don't want to do this, right? That's going to it's just not the right way to call it. You actually only give it one argument. In this case, it's a list of length 3. And a helper function that's really useful is np.ones, right? 1 by 1. There we go. And this will create a matrix of ones, and you just give it the number of rows and columns, or rather you give it the dimensionality, because we can do this, or we can do one of these, and it'll create a 3 by 4 by 1 dimensional array. And then there's that, just full of ones. I'm going to stick with 2 dimensions just because it's easier to illustrate. You can also do np.zeros to get a matrix full of zeros. You can do np.random.rand, and that would give you so you can also do np.random.rand and just give it the dimensionality of the matrix you want, and that gives you numbers between 0 and 1. So that's a nice, useful way to make up a matrix full of random numbers. What's really cool is that you can perform some basic operations just natively. So if we've got the matrix A and we've got the matrix B as np.array.ones, and that's a.shape. Boom. Oh, okay. There we go. So now we have A and we have B, and we can just sum them up. Boom. And it'll automatically add them up. We can do A minus B. We can do A squared, right? We can do A minus 1 to just decrement everything by 1. A times 2 to just double things, A times 5. So it's cool because it'll automatically broadcast. That's what's known as broadcasting. It'll broadcast this integer across every element of A. So it's nice because this Numpy will automatically do element by element math. We can even do np.sign of A, get the sign of every element. Right. So we can do a.t to get the transpose of A, which means we can do A times A will do element by element, or we could do A times A dot T. And if we wanted to do matrix multiplication, we use the at symbol to get the matrix multiple of A and A times T. That's just A squared, right? And this is the same as np dot dot A comma B, or A dot T, or A dot T. So there's a few different ways to do matrix multiplication. You can find the min, and let's see. You can find the min of an axis, which is really cool. So this is just a reminder of what A is, right? You'll get the min based on an axis, or you can do axis 0. And so the minimum along this axis, along the vertical axis, in this column is 1, then 2, then 3. And then if we were to do it across rows, right, the minimum is 1, then 4, then 7, and then 10. So this is A. One thing that's cool about Python, or about NumPy, is indexing different elements of A. So I could do A at 1, 1 to get the 1 by 1th element, and that's obviously 5. Or I can get all the elements in the first column, and similarly, or in the 1th column, which is really the second column, and similarly I can look at the second row and get all the elements, or the 2th row, which is really the 3rd row, because indexing starts from 0 in Python, and that's 7, 8, 9. We can also do the 2 through the end, and if I wanted just the 1th element there, I got 8 and 11. So that's the basics of slicing, and let's see. So for example, if we do A less than 8, right, we get this whole list of Boolean values, and we can use that as an index to get just the elements less than 8. We may want to iterate through A, and iterating happens axis by axis. So if we do for row in A, print row, as you can see, we just get row by row by row. We can, one thing that's really cool, so we have A, we have B, they're the same shape. Yeah, that'll be fine. And well, yeah, sure, A dot shape, B dot shape. There we go. Okay, just check they're the same shape. We can do np dot the stack A comma B. Oops. There we go. And it'll stack everything vertically. And if we look at the shape, you'll see it's 8 by 3 as expected. You can also do a horizontal stack with H stack and get something that's 4 by 6. And we're really just, smashing two arrays against each other. One quick note about copying A. If we make up a matrix or an array called A2 and set it equal to A, and then we set the element of A2 at 0, 0. If we set the first element of A2 equal to, let's just say 100, you'll notice that the first element in A has also changed. So what you really want to do is do A2 equals A dot copy, and then you can say A2 at 0, 0, set it equal to 99, and now you'll see that A2 has 99 in the first position and A has 100. It remains unchanged. And that's just, it's important to copy things as necessary to avoid any mishaps. You will want to go ahead and look through the documentation for Numpy. It's got a lot of useful functions. There's no way I could discuss all of them. Let's go ahead and review the statistics and linear algebra abilities of Numpy. So if I have A, I can do A dot there we go. I can find the covariance of a matrix. I can find the mean, and I can do it, in an axis by axis basis. I can do the same thing with standard deviation. And again, if I just want to find the standard deviation of all the elements, I can just do that. And so that's useful just to, get some quick statistics on rows or columns. You can do NP dot. We already showed A and A dot T. And you can also do the cross product A of 1 comma all. There we go. And let's see, you can do the cross product of that matrix. So Numpy does have a matrix tool, so we can do np.matrix to see that this library is available.